We have to cover this pozzolan or supplementary cementitious material, fly ash, GGBS, ground granulated blast furnace slag, silica fume, metakaolin, rice husk ash, which is included in IS 456-2000. It's already there. So last lecture we have discussed about fly ash and GGBS. Anybody is having any question on this? Otherwise, we'll proceed on further lecture.
Not yet, sir. I guess we should proceed.
Okay. So now next material is silica fume. You must have heard about this name in the market. And most of the high strength, high performance concrete, we are using this material as a replacement to cement to achieve our best performance in the concrete. So we'll just discuss about this material. Only thing is what is happening, first we discuss about fly ash and then we discuss about GGBS. Their replacement levels, maybe fly ash we can go up to 35% replace our OPC. GGBS as per IS code we can go up to 70% replacement. And some cases people are also using up to 80% replacement, mean 20 OPC is 80 GGBS, but it has got hydraulic properties also. Now silica fume is used in the percentage in the ranging from maybe 4% to 15%. In general case about 5 to 8%. Specific application we can go up to not more than 10%. So this we have to always remember about this silica fume, though there is a material, supplementary cementitious material. Silica fume, there is a specification in IS code. Earlier it was not there. We are following some international code. But now 2003 they introduced the code 15388. So this is the IS code for specification and chemical requirement of silica fume. This you can note down this code because it is very important. Because now whatever we are using high performance concrete, we are using this material very successfully. And it has got history, more than 20-30 years people are using this material for high performance concrete as well as high strength concrete. This is the physical look of the materials. You can see here. Now this material is very, very fine. Fine in the sense you can just imagine the average size of the material is about 0.5 micron to 1 micron level. So such a high fine material is very difficult to handle at site. So we'll just discuss how they are using that site. So basically it is a byproduct of electric arc furnace used for manufacturing of silicon metal or ferrosilicon alloy. Temperature around 2000 degrees Celsius. Fly ash we are taking from thermal power station, the coal ash. GGBS we are taking from steel plant. Now this is from ferrosilicon alloy or silicon metal. Now this is also collected in the various fields. Means fumes are collected. That's why these very, very fine spherical particles are there. You have to remember this shape is spherical particles. Average size may be 0.01 micron. And you can just see the fineness of this surface area, what you are normally taking for cement. See, this is 15,000 to 20,000 meters square per kg. In cement, it is around 300, 250, 280 to 300. So you can just remember the figure. So that's why it is very, very fine materials. With all other materials we are using in the concrete. Cement is finer, then we have finer fly ash, then we have GGBS. Now further finer is your microsilica. Relative density, specific gravity is around 2.2, 2.5, depend upon the ferrosilicon or silicon metal. But is in this range, 2.2 to 2.5. You can see the bulk density. If you take the volume, it is ranging from 80 to 320. So such a light material is there. So per cubic meter, we can weigh it is may varying from 80 to 320 kg per cubic meter. Then you can imagine how much particles will be available in per cubic meter of materials. This is a general idea about this open furnace, stack and pre-collection fan, and we have this fields, back filters, and we can have this number of other gases can go from here, and we can collect the material in this and packed into the bags or store into the silos, and further we can go in the bulk bags, maybe 500 kg or 1000 kg bags, or we can have normal 25 kg or 30 kg bags of this material. What is its chemical composition? Here it is a amorphous silica because it's very reactive in nature. That's why it is not crystalline. It is a amorphous silica, and silica minimum is around 85%, but generally it is available around 90% level. And then spherical shapes are very round surface, and traces of some element depend upon the fumes is available, so that is required. Physical properties, as I said, typically about 1 micron. Then as a product, this is the bulk density of the material. Now this can be used in 3 different forms as it is, depend upon the application where you are going to. Most of the this product are very high quality product, means around 95% plus SiO2 that can you use for your refractory product, where your temperatures are very high. We are making various product, refractory product. So there they are using this product. Then in concrete, you can use in these 2 forms. One is slurry form, where you can make 50% water and 50% of microsilica, make a slurry, put it into the agitating tank, and then we have to add also there is a stabilizer. Otherwise, it will not settle down in the slurry form, and that can be batch in the concrete to reduce the pollution at the site. Because it's a very fine material, if it goes into the lungs of the human, it may damage your lungs. So it is advisable to go for you can use in the slurry form using stabilizer, because if you see this project Bandra World Sea Link, they have used this material and they are using slurry form. There is another form is you can densify it. You can add some material and make some small granules. Small granules about size of maybe about 0.5 to 1 mm, 0.5 or 0.25 mm size, composing number of fine particles in one particle of that densified stage. So their bulk density is around 480 to 720. Now this 130 become 480. So number of particles, the size is bigger, and so though it is bounded with some material, so it is very easy to handle at site in powder form. So this we have to remember. One is coming under densified, one is undensified. This is undensified, and this is densified. Specific gravity is 2.2, and surface area is about 15 to 30,000 square area. About this. surface area of original sample. Densified will have slightly coarser material, but if you mix into the mixer, during mixing process, the balls are breaking and again it will come to the original form. So handling is easy for this volume. That's why we are using densified material only in the concrete, undensified material used in the refractory product or any other product which is where we required very reactive silica. So this is the particle size distribution. You can see here 0.1 to 10 micron. So most of the things is here. And D50 is around 0.5 micron. D50 means the particle, 50% particle passing through that particular size. Generally, when you are going for a powdered material and you do the specifying the material, you always specify D90, D50 and D10. That is material passing 50% level, material passing 90% level and material passing 10% level. So here average size is around 0.5. Cement D50 may be around 22 micron or 25 micron rather. So you can just imagine with the compare with the cement how the material is finer than cement. Then when you talk about high performance concrete, we'll discuss about how they are performing in the concrete. So you can see here SEM. As received, you can see here, this is 1 micron. You can see the 1 micron level, less than 1 micron. It is in spherical particles. Once it is dispersed, you can see this spherical zone. This is as received and it is dispersed. You can see it's perfectly spherical particles. Now you can see the comparison of your three materials we are using in concrete. One is silica fume, one is fly ash, and then you have cement. Now SiO2 content you can see here is 85 to 90%. 85 is the minimum required, 97%. Fly ash around 35 to 60%, and cement you have 20 to 25%. Cement, most of the things come as a CaO, calcium oxide, lime. But silica in this range. You can just imagine the surface area of microsilica around 15 to 30,000. Fly ash around 350 to 700. Minimum is 320 specified for fly ash when you are using directly into the concrete without grinding as it is. So that can be go up to 700 also. If you process further, we may get there more also. And then we have cement. Minimum is around 250, but normally it is around 280 to 300. And we have finer mud cement, we have around 500. So you just imagine the surface area, this to this, this to this, and this. So when you are using these three materials in concrete, what we have to do, this is a coarser material, this is finer material, and this is again finer material. And this you can replace around 35%, this you can replace around 6 to 8%. And balance is your OPC. So when you combine this, we have to see the particle size packing of paste. And once the particle size packing is very good, you will get high performance concrete and very high strength concrete also. So that is the technique how to go about high performance concrete. That when you are talking about mixed design, we'll discuss this again. So pozzolanic activity with cement, this is C reactivity 120% to 210%, depend upon particle size and SiO2 content. But this is the range. Fly ash 85 to 110. Minimum required fly ash is about 80%. So 85 to depend upon their fineness and silica content in the particular source of fly ash. Now, pozzolanic activity 8 to 11.4. So it's very high reactive material. Here 4 to 6. Your minimum requirement for fly ash is 4.5. So this is a pozzolanic activity when you are doing testing with lime and fly ash. Because lime basically CaO. So when you are adding in concrete, it is also reacting with CO coming from cement, and you are getting lattice strength. So that is the purpose. Here it's what happening is you get very good silica content, reactive silica. So early strength is also will able to achieve using these materials. So whenever you want to design very high early strength concrete, maybe within 18 hours or 24 hours, you are able to design a concrete using silica fume and OPC. It's possible. Within 24 hours also we can have design successful strength, maybe 30, 40, 50, whatever you want, we can design it in a 24 hours. So what is the advantage of this material is increase in the compressive strength because very high reactive silica is there, amorphous silica, which is reacting with your CaO available in the cement. Very high early strength, even on 6 to 8 hours also you are able to get the strength. If you are designed properly with the proper percentage, we are able to achieve early strength also, where we want to start or open the early traffic. So we can design for 8 hours or 6 hours also for the desired level of strength. Reduction in chloride permeability. Since the packing is very optimized, no pollutant will go into the body of concrete. So you design such a way that your water permeability, air chloride or air permeability is minimized. That is possible with the using this material. Improved in abrasion resistance since it is a silica. So wherever you want abrasion resistance concrete or chemical resistance concrete, we can go with microsilica or silica fume. So it is also with the control with OPC, and if you see OPC plus microsilica, you will have resistance is excellent. Now less rebound in the shotcrete. Shotcrete, one of the application of concrete, when you do the tunneling, and in the tunnel we have to do the lining. So we use gun, means you can spray the concrete with the force to the concrete surface. Now since the material is very fine, material become very sticky and cohesive. So your rebound loss is less. That what is less rebound loss in shotcrete. So most of the tunneling lining people are using this material along with OPC and have a better performance in reduced cost wise also and get better performance in shotcrete. Reduce washout under tidal conditions. Since it is a impermeable concrete, your permeability is reduced, your salt deposition is reduced, and will get very good washout is reduced compared to normal concrete. Now, in this, some of the disadvantage, not disadvantage, but this has to take, whenever you are designing the concrete, we have to take care of this material. Not we are not saying directly disadvantages, but this has to be keep in mind when you are using this material. You required very high range water reducing agent. Because since it is very fine, you will find your water demand is going very large compared to OPC. Any fine material if you use, definitely there is a surface area is very high. So pest requirement is high, so water requirement is also very high. To reduce the water, you need high range water reducing agent, HRWR, high range water reducing agent. Means in the category of admixture, if you see, we go for the higher grade, maybe 20 to 30% water reduction level. Those admixtures we can use for when you are using in the this microsilica in concrete. Concrete become very cohesive and sticky mix, especially with higher dosage. Higher dosage in the 6 to 8%, 10%, you will find concrete become a very sticky. It's very difficult to even place the concrete or vibrate the concrete or finish the concrete. Then to come out with this, we'll have to work with the water reducing, proper water reducing, compatible water reducing agent to reduce the cohesiveness, and they adjust the fine to coarse material to get minimize stickiness in the mix. Because all these high range water reducing agent having a some part of polymer as well as VMA, viscosity modifying agents. Most of the admixture they have in this. So whenever you're using, your segregation is reduced. It's very easy to pump. So if you add this material, you become very sticky and very difficult to pump also. So those has to be to lot of trial and error, discuss with the admixture people, and then only we get the compatible, suitable admixture for the particular application. General admixture may work, may not work. Practically, there is no bleeding because huge power water demand. So there is a possibility of plastic shrinkage crack. To come out this, we have to protect concrete immediately, or you can start curing immediately after placing. Otherwise, you will get evaporation loss and you can see the plastic shrinkage crack on the concrete. So that we have to take care, we have to manage that. And higher shrinkage and cracking if you are not cured properly. Because most of the concrete is cured after 24 hours. But nowadays, most of the concrete where you are using 53 grade cement, where reaction starts very immediately, and using some admixture, so water cement ratio is water binder ratio is very low. There's a possibility that we are using low water content and the surface water may be evaporate because of the ambient temperature and ambient humidity. There's a possibility you get shrinkage cracks. So you have to start curing immediately after placing. You should not wait for 24 hours and do the cure. You at least cover with the plastic sheet or sprinkle water immediately after placing, maybe within say 1 hour or so, or half an hour or so, and then you can subsequently you can do the ponding on water curing after 24 hours. This is what we have already discussed. Slurry is mixed with 50% water. Densified the basically why we are densifying, better for transportation, reduce the dust and easy to handle. And with this range only bulk density will be there, and it is always more than this, it will have difficult to disperse in the mixer. 1.1 as to you can note down here, whenever you are using this material in concrete in your batching plant, basically it is recommended to use a pan mixer or twin shaft mixer for this. So your mixing time has to increase maybe about 50% time. If once you are using about 30 seconds or 40 seconds, it has to go to 60 or 90 seconds minimum mixing for dispersion of this densified material. If you use minimum time, which is normally used for concrete, which will not mixed properly, and you will have erratic results. And you may not get the benefit of the material. Once it has not broken the materials or dispersed the material and all the fine particles are should available for hydration or combine with the cement, then only we'll get whole potential of that material. Otherwise, we may not get. So mixing time, this you note down in your notebook. Mixing time has to be increased when you are using any microfine material, not only microsilica, any microfine material. We have to increase the mixing time in batching plant. Undensified, as I discussed, we can use only in the refractories or some special applications, some grout material. People are using this in undensified, where the quantities are very small. Another way you can use is a slurry. You mix it with 50% water, make a slurry, keep agitator in the tank, and also you have to add some stabilizer. And that particle should not be settled. Otherwise, only you can add when you are batching, you get only partly water only will get. Here, slurry should batch. So batching arrangements are available today in the market for the batching plant. We can pump the slurry in the weighing hopper, and whatever water available in the slurry form can be reduced from the total water for the design mix what you have used. Because when you are designing, you may be in powder form. And when you are batching actual production, you go in the slurry form. So extra water available from the slurry, that has to be reduced from the main total water, designed water, maybe free water or total water we have designed it. Suppose it is 200 liters and 50 liters coming from this slurry itself, then we'll have to use only 150 liters of water. That also precaution one has to take. This is the physical requirement given in IS 13588. That is the code number I have given you. Oversize retention 45 micron is 10% maximum. Average may be 5%, and compressive strength with the control is around 85%. Fineness is 15,000. This is meter square per gram. If you collect cubic square meter per kg, it is 15,000. So that is the minimum fineness for the material requirement. So out of this, any one of the thing is you can use as a acceptance of the material. So one of this and fourth one, this is mandatory. Control should have around 85%. The procedures are given how to go about compressive strength of 7 days with the control sample. Minimum 8 days is come around 90 to 100 actually, when you have good quality materials with you. This is a chemical requirement. As I said, SiO2 minimum 85%. Moisture maximum 3% is allowed. If the moisture is more than this, there's no harm in the quality of the material, but it is very difficult to handle it. Because most of the time you use in the screw conveyor, and the screw conveyor, it is not able to patch properly. That's why this limit has given. LOI means carbon levels may be around 4%, and alkali is about 1.5%. So this is the requirement for chemical requirement as per Indian standard. As I said earlier, replacement or addition, both the way we can work, is a 5 to 10% levels of weight to weight of cementitious material. This one has to remember always this. Sometimes we can go even 15% or the specific requirements. Suppose you have to design chemical resistance floor, concrete floor for the factory where you are handling chemicals. This may go up to maybe 15%. The general concrete, high performance concrete or high strength concrete, even If you design M100 also, more than 10% is not advisable to use. Because mixing is difficult. Mix become very, very sticky, very difficult to handle. Maybe laboratory we can design it, but one has to see that how I can make concrete in the field. So that one has to see, and accordingly we have to fix up the dosage of your materials. Increase the water demand because very fine material. Use high range water reducing agent. We are using PC based admixture, polycarboxylate admixture we are using most of the time. But I remember when we are working for JJ flyover, you must have heard it is in Mumbai, around 2.2 kilometer viaduct JJ flyover. There we have used M75 concrete first time in the country. So there we have used this material, and that time PC admixture was not available. So use only sulfur naphthalene formaldehyde SNF based material, but very high range of SNF we are used, and we are experimented up to 6 months to get that particular admixture because I only designed that concrete M75 for JJ flyover, and that concrete we have batching plant at Vadala, and from there we have to transport the concrete at Bendi Bazar. You know that area is very, very congested area. So all the column you can see that is 8.35-meter height cast in one go. So there we have used this high water reducing agent admixture, but SNF based. And mixing time. Most of the batching plant designed maximum mixing time is around 60 seconds. Normal mixers or normal OPC mixes, 30 seconds is also sufficient for making half cubic meter or 1 cubic meter batch. That is the design, general design. But when you are using, we have to tell your plant manufacturer that when I'm using handling this microsilica, I have required double the time, is 2 minutes. So whenever we got the plant for this particular project, we ask the manufacturer to incorporate because all computerized systems are there. Once you set that, everything will go automatically. So mixing time has increased up to 90 seconds, and sometimes even 120 seconds we are used to get a better dispersion in the cementitious system. This what I have to remember this. As I said, air entrainment is there, high water demand, worker becomes cohesive, bleeding is minimum, potential for plastic shrinkage cracking. Why I am repeating this? Because this is very rarely we use this material for the specific application, and without understanding if you use this, will enter into lot of problems for placing as well as setting may be delayed due to the high dosage of HRA. So we have to get tailor-made material. Even I go for higher dosage, my setting should not be delayed. Setting of concrete. I am not talking of setting of cement. This will discuss when you talk about fresh properties of concrete. Hardened concrete, high early strength, minimal gain 28 days, and you will find that you will get around 80-85% strength in 7 days itself because of very high reactive silica in the concrete. And then later age, even after 28 days, you may not get much strength. If you use fly ash or GGBS, after 28 days, even up to 1 year or 10 years, the strength is go on increasing. But with the silica fume, it is limited around 90-95% strength is gained in 28 days only. Significant improvement permeability. This is our basic aim for high performance concrete. Very dense paste. Improved aggregate interface. This also we'll discuss when you are talking hardened properties of concrete. Because in any concrete, paste and interface is very, very important. Once you're able to manage that interface, you'll able to get a very good concrete, very good high performance concrete. And as I said, resistant to penetration of chemicals and is also act as a durability enhancer. Now, other than this, lot of other microfine materials are now available in the country. So that we'll discuss in a separate lecture, microfine materials, which is other than microsilica. Application, high strength, high LC, abrasion resistant, corrosion protection because prevents chloride ion, good for marine structure. Most of the marine structure all over the world, we see the literature, people are use silica fume in the concrete. Very good sulfate resistance, chemical attack, and also get advantage in shotcrete concrete. So these are the major advantages using this material, but it is also you have to keep in mind your cost. It is also very costly material. Around 5 to 6 times of your cement. The cost of this material is about 5 to 6 times in the market.